So average velocity formula is x2 minus x1 by t2 minus t1. Average speed formula is total distance by total time taken. When will the average velocity be equal to average speed? Okay, so that will happen only when the displacement vector will be equal to the distance itself, and this can happen only when the object is moving along a straight line. So when the object is moving along a straight line, the change in the position will also be the same as the distance. So when the object is moving along a straight line, the average speed and the average velocity will be equal. So first question has been answered. So a car travels for half of its time at 80 km per so half of its time, say the time is t by 2, total time is t, and so for t by 2 it's traveling at 80 km per hour. You want to convert it into meter per second, you can, or you can retain the answer in 80 km per hour. For the rest of the half the time is going at a 40 km per hour. Okay, so t by 2, next to t by 2. Then the total distance covered is totally 60 kilometers is the total distance covered. And then it will not be equal distance, because he is going at a different speed. The fact that he is going at 80 km per hour, he would cover greater distance. So ideally this takes t by 2 half the time, but this is going to cover a greater distance and this is going to cover a lesser distance because the fact that this is greater speed. So then if you are going to consider that let's consider this distance as d1, or you can even consider this as x and this is 60 minus x. So you know that find the average speed. You all know that average speed formula, average speed is total distance by total time taken. Total distance by total time taken, and the total distance is 60, as you know, and the total time taken, you don't know what is the time taken. Yeah, so let's calculate the time taken. To get the time taken, let me think how we can get that. Can you see that there is a speed and there is time, which will be distance, because velocity is equal to distance by time, distance is equal to velocity into time. So x is also 80 into t by 2, and 60 minus x is also 40 into t by 2. So this and this get cancelled, so you get 20t, and x is also 80 into t by 2. I hope you are clear. This distance is, this part of the distance is x, this part of the distance is 60 minus x. Right side is left side is x and 60 minus x on the right side. So this and this get cancelled. X is equal to 40t, and 60 minus x is equal to 20t. So x 60 minus 20t is equal to x. Therefore, we can equate this one and this one. So when you equate that, you get 40t is equal to 60 minus 20t. Taking it that side, you get 60t is equal to 60, which means the time taken is 1 hour. You just get 1, it has to be hour because we didn't convert into meter per second. So then the time 60 kilometers is the distance, it is in kilometers, so you don't have to change anything, it's 1 hour. So then therefore the average speed is 60 kilometer per hour. So next is sum is sorted. When it's already in kilometer an hour, every unit is 60 kilometer an hour, you don't have to change the unit. So the next question is, ball is projected vertically upward, so you're throwing it, we're giving it an initial velocity. So the final velocity here will be 0. It becomes back to the ground in the same time. It's just going to hit the ground because the velocity gets to 0. What is the VT graph? You know what is the VT graph for it. The topmost point will be the bottommost point in the graph, and it's going to come down. This is the velocity time graph, as you all know. We are done with it, and whichever is the option, you have an option C. Okay, that's the right answer. So let's go to the next question. The position of the particle moving along the x-axis is x is equal to 10t minus 2t square. Then the time at time t at which it will be momentarily come to rest. So it has to come to rest, which means the velocity has to be 0. If it has to come to rest, the velocity has to be 0. So let's find velocity, which is dx by dt. A differentiation of 10t is 10 minus 2t square is 4t. So when the velocity is 0, it's 10 minus 4t, so t is equal to 10 by 4 or a 5 by 2, which is 2.5 meter per second. So that is your answer B. Let's go to the next sum, fifth question. The next sum is two bodies A and B. So let's consider a body A and another body B of mass 1 kg, another mass is 3 kg respectively. or dropped from height of 16, it's been dropped from a height of 16 meter, and this has been dropped from a height of 25 meter. Okay, so when they drop it, you know the initial velocity is definitely 0, u is equal to 0. The ratio of the time taken by the body to reach the ground. Okay, so you know the distance, and you know s is equal to ut plus half a t square. In this case, s itself is 16 meters, u itself is 0, so ut will become 0. Half into the body is coming down, so you can call it as 10, is the gravity positive 10 into t square. This and this get cancelled, t square is equal to 16 by 5. T is equal to root of 16, which is 4 by root 5. It's 4 by whatever root 5 is, if you can fill in and you get the answer. So let's go to this. S is equal to ut plus again half a t square only. U is 0 and s itself is 25, and half into 10 into t square. This get cancelled, t square is equal to 5. So t is equal to root 5. So you get a 4 by root 5 and t is equal to root 5 in one of those. So what is the time taken by the ratio of the time taken for them to hit the ground is 4 by root 5. It's supposing this is T1 and this is T2. T1 by T2 is 4 by root 5 by root 5. The big by is here. So 4 by root 5 into root 5. It's like root 5 by 1, right? So 4 by 5 is the ratio. And if you have an option 4 by 5, which is option A, you can tick that. Okay, let's go to the next question. So the next question is the sixth question. If the tangent at any point of a position time graph, let's do an xt graph, this is it, is parallel to the, so for some curve the tangent is parallel to the time axis, yeah, it's like this. Then the instantaneous velocity, you can't do a slope for this, you all know velocity is the slope of an xt graph, it's one step higher, so velocity cannot be done, and so instantaneous velocity itself is 0. What is instantaneous velocity? The word instantaneous velocity means v is equal to dx by dt or a delta x by delta t, limit of delta t tends to 0. That is what is instantaneous velocity, just for you to understand how to present it, okay. But normally it's delta x by delta t. See, next question, I am not sure. Dash is the time taken, dash is the time a person takes to think and take some action. I don't know, reaction time? I don't know what time to think and do an it is can we say instantaneous? Can we say the word instantaneous? He does, you know, somebody, some dust particle comes and falls on our eyes, instantaneously we close it. So can we say instantaneous is the time, or reaction time tends to be instantaneous? That's what I would write. I'm not sure. You check with your teacher on this. A train 100 meter long is moving with a uniform velocity of 45 km per hour. 100 meter long is moving with the initial velocity 45 km per hour uniform velocity. What is the time it takes to cross a bridge 1 km long? So you have to convert them into meter per second because it's 100 meter. So it's 45 into 5 by 18. You don't get a good answer, then you can convert this into 0.1 kilometer. You can convert this into kilometer, and you know this is the distance and this is the velocity, and to cross the bridge 1 kilometer long, the train has to come here, literally here, which means the guard of the train should move past the bridge, which means it has to cross this 100, that is 0.1 kilometer, plus he has to cross the 1 kilometer plus another 0.1 kilometer, which makes it what is it, 1.2 kilometers. The total distance that it should travel is 1.2 kilometers. And so how long will it take to cross the bridge? Okay, it's traveling at a speed is 45 km per hour, distance is given, velocity is distance by time. So then therefore t is equal to distance by velocity, which is 1.2 km by 45 km per hour. If you can divide this and write the answer, that will be the answer in hours. Okay, the answer that you will get is in hours. So you can write 12 by 450, then you can cancel, it will be in decimals, whatever be the hours, and you can multiply it with 60, you can convert it into minutes and so on. So this is the way. So let's go to the next question, the ninth question. When a moving object considered as a point object, give an example. I told you that you know, it depends on the distance the moving object is traveling. If a small tumbler is falling from the table to the ground, it will be not a point object. When the same tumbler goes to Delhi from Chennai, it will become a point object. It depends on the distance it travels. Correct, the point object. Okay, a kite in the sky will be a bee in the space, a bee, honeybee in the space will be a point object. Whereas say what else I can say, a cricket ball on the ground will be a point object. Whereas you falling down from, you jumping from the table will not be a point object. So that's about it. So you can write these as examples. Let's go to next. The next is a 10th question. So point object is one where the distance covered is lesser when compared to the size of the object. Distance covered is, say distance covered is more, distance covered is very long when compared to the size of the object. That's when you say it as a point object. Let's go to next question. Plot the position time graph for the motion of an object moving with a positive acceleration. You know, positive acceleration, the acceleration time graph is this. The negative acceleration means the acceleration time graph is this. Plot the position time graph. So what would have been the velocity time graph for this? It would have been like this. The velocity time graph for this would have been like this. So what will be the position time graph for this? The position time graph, it is basically, position time graph would have been, okay, so the position time graph for this would have been for the two positive acceleration, negative acceleration. Okay, once again. So this, I am not able to do a position time graph here. So I am just thinking and I decided that it's not this. Okay. So when the acceleration is negative, you know, acceleration is a vector. So therefore just correct it. The acceleration cannot be like this. It has, okay, it's got to be like this. Okay, one second. The acceleration is negative. Okay, the acceleration is negative, it will be like this. This is called negative acceleration. When the acceleration is positive, okay, sorry, so then it's not about an increasing acceleration, it's about a negative and positive. An acceleration time graph, this will be positive and this will be negative acceleration. If this is negative acceleration, what would be the what will be the position time graph? Now obviously when it's parallel to x-axis, you know that the position time graph xt should have been like this, and the position time graph for this positive acceleration should have been like this, because when you do a slope for this, you get a velocity time graph which is like decreasing, and so then therefore you get a negative acceleration. So then acceleration time graph is negative. So I hope you understood. This is negative acceleration and this is positive acceleration. So origin, okay, with respect to origin. So it's done. So this is how you draw the position time graph. Next is section B. Okay, so section B, what is the question? The velocity time graph of the body is shown here. Can you see that the diagram is like this? Okay, so the diagram goes like this. It goes like this and comes like this and then goes straight like this and goes like this and goes like this. So this is EF, there is D and there is A and there is B, and this is 0 and this is 3 and this is 6 and this is 8 and this is 10 corresponding values, and this is time graph and this is a velocity time graph. And you know this point here is 15. This point here is 15. The point E, the E point, that is this corresponds to 10 meter per second, and there is this point which is a C which corresponds to minus 10. Obviously it's the 5. So yeah, this is the graph that's been given. What is the question? The velocity time graph is given below. Find the distance travelled by the body, the displacement of the body. Distance travelled means, I told you, whether it's negative or positive. In a VT graph, you want to find the distance. It is one step below, so you have to find the area under the graph. So area under the graph, area under this region 1, area under the region 2 and area under region 3. All the 3 can be added. Area 1 plus area 2 plus area 3 will give you the distance travelled, distance. When it's displacement, you just have to do area 1 minus area 2 plus area 3. Okay, so then that is about it. So when it's displacement, I told you this already, you just have to calculate the area. So what is it? For the first area, it's half into base. What is the base? Is this, can you see this distance, which is 6 into this height itself is 15. So that's area 1, and area 2, this is the base, and this will be between 6 and 8. It's half into 6 and 8 is difference is 2 into height will be this height which corresponds to y-axis, which is 5, plus area of the triangle 3 is half into this base, which is I don't know what is the end point. I think the end point is not being given, but I can take it as a symmetrical triangle. So then for 8 to 10, and so therefore I am assuming it to be 12, and so the entire distance is 4, half into base which is 4 into height itself is this, which corresponds to 10 units if you see here. So into 10, just calculate this, add everything, you get the distance, you put a subtraction symbol in between for this area, you get the displacement. So that's done. So let's go to next question. So 12th question, derive an equation for the distance travelled by a uniformly accelerating body in the nth second of motion. Is nth second, I have already taught you this, nth second, the distance travelled is actually Sn minus Sn minus 1, Sn itself is ut plus half a t square, which will become actually un plus half a n square. So un plus half a n square, and Sn minus 1 is u into n minus 1 plus half a n minus 1 the whole square. As I told you, you have to just subtract Sn minus 1 to get the nth distance, okay, distance travelled in nth second. Sn minus 1 is un plus half a n square minus un minus 1 plus half a n minus 1 the whole square. You just put a bracket and solve it. It's there in my previous video, okay, the rough video that I have made. You get the final answer to be u plus a by 2 into 2n minus 1 while doing this, okay. So I am sure you all can look at the video and learn that derivation. Let's go to part B of the sum. This is just part A. A body is moving with a uniform acceleration. With the velocity after 5 seconds, okay, the body is moving with a uniform acceleration, which means the velocity is constant, okay. Its velocity after 5 seconds, so it takes a time of 5 seconds, and at this point it gets to a speed of 25 meter per second. And after 8 seconds it is 34 meter per second. After 8 seconds, so till here he comes here at 8 seconds, and at this juncture he is increasing to 34. It is 34 meter per second. Calculate the distance it will travel in the 12th second. 12th second means S12th, which is u plus a by 2 into 2n minus 1, where n itself is 12. So 24 minus 1, so u plus a by 2 into 23. So all that you need to know is u and a, which you need to find out from here. You know the initial velocity you don't know, but you know the final velocity at this instance is v25, which takes a time of 5 seconds. So v is equal to u plus at. So then you know v is 25, you don't know, a is acceleration, again you don't know, so a into 5. So you get a linear equation like this. So from here to here, let's do it. From here, the initial velocity for this journey, the initial velocity is 25, the final velocity is 34. So again putting v is equal to u plus at. Here the final velocity is 34, the initial velocity is 25, plus a into time it takes us 8 seconds. So this it's 34 is equal to 25 plus 8a. So thus you get two equations, and if you solve this, you must be getting the answer. So guys, just one change to get the answer. What I suggest you to do is, don't take this as consider this as, don't take it as 25 for this journey. Let's consider it for the full journey, okay, for a change. Okay, I was just thinking, yeah, let's take it for the full journey. Then in that case, the final velocity at because 8 seconds, let me read the question. Is it from the beginning is 8 seconds or after 8 seconds? Then after 8 seconds, is it from the beginning? If the velocity after 5 seconds is 25 meters, after 8 seconds, so from here to here it's 5 seconds, considering from here to here it's 8 seconds, then I have to take it as u if I am going to use 8 seconds from the beginning, not for this gap, okay. In that case, this will be 34 is equal to u plus 8a. So 34 is equal to u plus 8a, and you can solve this like a linear equation and get the value. So 34 is equal to u plus 8a, and 25 is equal to u plus 5a. So minus, so 3a is equal to 9, so a is equal to 3. So I hope it's getting recorded. I am not able to see if it's getting recorded. So a is equal to 3. Thus you get, once you get the acceleration, you can put it back and find the velocity. Velocity will turn out to be 10 meter per second in one of the equations. Once you get that, you know a, you can substitute in this formula and find the distance travelled in the 12 seconds. So that's about session C. Yeah. Yeah, then it's the 13th question. Deduce an expression for the relative velocity of an object with respect to another. Represent the motion of the two objects with zero and non-zero velocities using position time graph. Motion, okay, deduce an expression for relative velocity of an object with respect to another. You can say this is object A, this is object B. If both of them are traveling in the same direction, if you want velocity of A with respect to B, it's VA minus VB. And if they're coming in the opposite direction, A is like this and B is coming like this, velocity of A with respect to B will be VA minus of minus VB. So then eventually it become VA plus VB because it's traveling in the opposite direction. So what else I can say? That's all I can say about the expression for relative velocity of an object with respect to another. Okay, so this is a simple, there's a big derivation there, but I'm not doing that, there's not enough time. So this is about section A, and section B is represent the motion of the two objects with zero velocity. If it's if it's going to have zero velocity, the object should be like this, xt graph should be like this, so that it's not accelerating. The object has to be static, and a non-zero velocity using position time graph. So then non-zero velocity is this, an object is moving along a straight line, you can say that it's non-zero velocity. So this is again position time graph. Answer C, two parallel rail tracks runs north to south. Two parallel tracks run north to south. This is north and this is south. North to south. The train A moves north with the speed of, the train A is moving north towards north with the speed of 54 kilometer per hour. 54 into 18 by 5 by 18 you can do, okay. And the train B moves with the speed of 90 kilometer per hour south. Train B is going like this at a speed of 90 kilometer per hour south. Okay, what is the velocity of B? This is B and it's going like this. The velocity of B with respect to A is VB minus VA. VB is negative y direction, downward is negative y minus 90, and 54 is the positive x direction, so positive y direction. So whatever is that, 9 plus 5 is 14, minus 144 meter per second or kilometer per hour will be the speed at which the relative velocity of B with respect to A is VB minus VA. And then velocity of the ground with respect to B. Velocity of the ground with respect to B is Vg with respect to Vg minus Vb. You all know ground is not moving, only the velocity of B is going, and that is negative, so minus 90. So it's 90 kilometer per hour. For the person who is going in the train, the ground will appear to move, appear to move. That's all. I'm done with this paper.